Hello and welcome to Fun with Physics. My name is Mr. Spensieri, and today we continue on in the series of lectures of electricity and magnetism. Today we look at how to measure the current in an electric circuit. Electric current is basically the measure of charge that travels through the circuit at a specific point. It's a speed, if you will, of transfer of the charge through an electric circuit. The unit that we use in the metric system to measure the electric charge is known as the ampere and is given the symbol capital A. We all know that it's electrons that are free to move in an electric circuit, causing the transfer of electric charge. And the motion of electrons moves from the negative end of the battery to the positive end of the battery. However, the direction of electric current is in the opposite direction. It is thought of as movement of a positive charge in the replacement of the negative charge that's moving. Therefore, electric current is actually given the opposite direction to the direction of electron flow. To measure the electric current running through a circuit, a device known as an ammeter is used. In circuit diagrams, the ammeter is symbolized by using a circle with a capital A in it. The ammeter basically measures the motion of electric charge through a circuit and must be connected in series with the actual circuit, so within the actual circuit, in order to measure the current flowing through that pathway. So in this simple circuit, if we wanted to measure the current that is traveling through this circuit, let's show the current for example, the conventional current, I would have to take my ammeter here and place it in series or within this pathway of electricity, of current flowing. And you notice as I place it in, we get a reading of 0.67 amperes. If I were to place the ammeter in another position in the same pathway, you'll notice that the current is still 0.67 anywhere we place it. And when we turn and we open the circuit, the ammeter doesn't give us a reading because no current is flowing. To calculate current, simply take the total charge that passes through an area in the given amount of time that it takes. This is the definition of what an ampere measures. 1 coulomb of charge per 1 second. So for example, if we wanted to calculate how much current flows through a hairdryer if 1400 coulombs of charge pass through it in 2.25 minutes, all we have to do is take our charge and convert our time into seconds and use the equation above and solve for a value of current in amperes. And in this situation, it would be 10.4 amps. Moreover, we can rearrange this equation to solve for charge or even time. For example, number 2, it says, your night light uses a 7-watt light that draws about 6.0 times 10 to the negative 2 amps of current. How much charge passes through this bulb in 8.0 hours? Well, here are all our givens and unknowns. And if we're looking for the charge, we really don't need the power, but we can use the current and the time, once converted into seconds, to determine the charge that is transferred in coulombs. Rearranging the equation above, we get that the charge is equal to the current times the change in time. Once we plug in our numbers, we get a value of 1.7 times 10 to the 3 coulombs. Example 3 is a continuation of example 2. In this question, we are asked to solve for how many electrons have passed through the night light with the same given charge and the same time and current. To calculate this number of electrons, we'll go back to the equation derived by Robert Millikan, which relates the number of electrons to the overall charge and the charge on one electron. Rearranging this equation, we solve and determine that approximately 1.1 times 10 to the 22 electrons have passed through the light bulb of this night light through this time. As mentioned before, the direction of current is opposite to that of the motion of electrons. Electrons move from the negative end of a battery through to the positive end of the battery. However, the conventional current moves in the opposite direction, from the positive to the negative. This type of motion is known as a direct current motion or a direct current circuit because the current travels in one direction only. There are also alternating currents in which the movement of the electrons and therefore the current itself moves back and forth repeatedly and produces a frequency of pattern of this moving back and forth pattern. This is known as alternating current.